In this video, we're going to look at some review problems that you will encounter on both the IXL and the quiz. Remember, though, I want you to go back into the first lesson we looked at with factoring polynomials, which was taking out the greatest common factor. And then the next lesson was looking at coefficients of 1 with the quadratic function. And then we looked at coefficients that are not equal to 1 in the quadratic and factoring that. And then last, we looked at special cases. We looked at the difference of two squares and a perfect square trinomial. So go back, review those, because those will be on the quiz and on your IXL problems. But here are three more just to kind of look at a couple different ones. So we're going to look at problem or example number 1 here, and you will see this both on your IXL lessons and on the quiz. So if you look at this, first of all, the first step always is to take the greatest common factor out. And again, it's totally up to you. Some of you can just kind of look at it and know that the greatest common factor is 8. Some of you will take your calculator and just divide by all the numbers you can think of. And some of you can just go through your factors of what equals 128 and 200 and then figure out that the greatest common factor is 8. Practice that a couple lessons ago. Use whatever strategy makes sense to you. So your greatest common factor in this time is 8. And the first step we do is just divide this whole thing by 8. So we have a smaller binomial to work with. So we have 200x squared divided by 8 leaves us with 25x squared. And 128 divided by 8 leaves us with negative 16. Hopefully, at this point, you recognize what we have left. So in our last lessons, we looked at special cases, and this is the special case of a difference of two squares. And I can tell, first of all, because it's subtraction, and second of all, both 25 and 16 are perfect squares. So we're going to put our double parenthesis there. Don't forget to bring down that 8 because you have to multiply it by 8 to go back to the 200x squared minus 128 when we check it. We're going to take the square root of 25x squared, which would leave us 5x and 5x. You take the square root of 16, which is 4. And remember, one of them has to be positive and one of them has to be negative. Now, if you want to double check to make sure you're right, remember the opposite of factoring is multiplying. So if you multiply this out, it should go back into that example number 1. So in this case, you'd have to multiply that 8 first. I'll just check this one with you so you understand. So 8 times 5 would be 40x. 8 times 4 would be the 32. So I just distributed that first 8 to that first set of parentheses. And then you're going to have to multiply two binomials. Again, some of you like to do it vertical. Some like to multiply it diagonal, horizontal. Some of you like to do the square method. Just whatever way makes most sense to you. I just usually do horizontal. So 40 times 5x, so 40x times 5x goes to that 200x squared. 40 times negative 4 gives me negative 160x. And then I'm going to distribute the 32. So 32 times 5x is a positive 160x. And the 32 times the negative 4 leaves me with 128. So looking at this, combining like terms, these two terms cancel each other out. So we have proven that we factored out correctly because our final answer is the same with what we started with. So this is our factored form. Again, I was just showing you how you can check it to guarantee you're getting them right. Our next example is 10x squared minus 75w plus 65. Again, greatest common factor. And I can see that right away. They're all factors of 5. So I'm going to guess my greatest common factor is 5. So I'm going to take that 5 out. So 10w squared divided by 5 leaves me with 2w squared. 75w divided by 5 leaves me with negative 15w. And 65 divided by 5 leaves me with 13. Now, I look at these coefficients that's left, and I can tell that there is still no greatest common factor. So if you do this and you divide out and then you notice that you still coefficients with what's left is not the smallest it can be, then you can take another greatest common factor out and make it even smaller. Just remember to multiply those greatest common factors you took out the first time. This one isn't a perfect square because 13 isn't a perfect square. Either is 2. So on this one, we're just going to have to factor. Again, some of you have your strategies. Okay, I'll do the box method strategy because I think most of you did it that way. But if you like the grouping strategy, that is a wonderful strategy to work with too. So this would be 2w squared. This would be your 13. What's nice about 13, it's prime. So my only choice here is 1 and 13. 2w will be 2w and a w. Now this is where we have to be a little careful because we got to put them in the right spots. And I want negative 15. So if I put 2w here, that's probably not going to be a good case because 2w times 13 is going to be way more than the 15 we want. So I'm going to guess that we're going to go with the 2w here, the w here. Let's check our math. So to get this box, we have 13 times w, which is 13w. We have 2w times 1, which is 2w. Now, a couple things. Number one, we got our positive 13 by taking 1 times 13, but if you notice, we add these up, it equals 15, but we want a negative 15, which tells me then the signs on the 1 and the 13 have to be negative, because negative 1 times negative 13 is 13, but when we add them here, because now those will be turned negative, now we get our negative 13. So we write down what we see. Again, it doesn't matter which order we put them in, so 2w minus 13, and on the side here is w minus 1, and we have nicely factored example number 2. If you want to check it, I won't take the time, but if you check it, take 5 times either one of these and then multiply it all the way back out, and you should, if you have it correct, get back to 10w squared minus 75w plus 65. Last example, you will see this on your IXL, again on your quiz too. This looks a little bit different than what we've seen before. This is going to, for those of you that didn't do that grouping strategy, this is going to force you probably to do that grouping strategy. So again, that grouping strategy, you just take the first 2 terms and the second 2 terms and you group them together. And all you're doing in that is then taking the greatest common factor out that we've been practicing over and over. So if I look at this first one, I look at 4 and 8 as my coefficient. My greatest common factor, of course, is 4. Now I'm going to look at my p's. I have 3 p's here. I have 2 p's here, which means that my greatest common factor is 2p. And then I have 1y and 1y, which leaves me with y. Now divide it. So we're going to take 4p to the third power y divided by 4p to the second power y. The 4's will cancel out. I get one little p left, and then the y's cancel out. Again, divide again. 8 divided by 4 is 2. That's a positive there. My p's are going to cancel out. My y is going to cancel out. So I know I'm completed. You do the exact same thing with the other grouping. So we have negative 8p to the third power minus 16p to the second power. Greatest common factor, negative 8. You remember you want to take that negative out. 3 p's here, 2 p's here, so I'm going to take out 2p. So I have negative 8p to the third power divided by negative 8p to the second power. Remember, I can show that really quick if you kind of forgot how to divide. So negative 8 divided by negative 8 leaves you with nothing or 1. And remember, you subtract the exponents, which would leave you with 1p. And then negative 16p to the second power divided by negative 8p to the second power. Your p's cancel out because 2 minus 2 is 0. And negative 16 divided by negative 8 leaves me with a positive 2. Now, I like this strategy because at this point, if you look at this, your 2, what's in your parentheses, should be the same. So if you don't get the same thing in those 2 parentheses, something mathematically went wrong. Go back. You might not have the greatest common factor out, or you didn't divide correctly. Now, p plus 2 is one of my new groupings, and then what's outside is my other grouping. So 4p to the second y minus 8p to the second. Now, you think you're done, but you're not, because if you look at this first, we know we factored out all the greatest common factors on that second set of parentheses, but this first set of parentheses still has some greatest common factors out, so we have to do it again. So 4, negative 8, I'm going to take out 4. Remember, you don't want a negative coefficient in the front. So I don't have to take a -4 here because that would turn that negative. 2p's, so I can take a 2p's out. And y on the first term, no y on the second term, so that's all I can take out. So we're going to divide. So 4p to the second y is divided by 4p to the second, so it's going to leave us y. And then -8, write that off the side if you're visual, divided by 4p to the second. Well, the p to the second, 2 minus 2 is 0, and -8 divided by 4 is -2. So that first set of parentheses turned into 4p to the second times, so y minus 2, and then you bring down your p plus 2. And then, just to make sure it looks right, look at your 2 sets of parentheses. If it doesn't look like you can take any other greatest common factor out, you know you're done. So that is the final answer. Again, if you want to check it, you can multiply these 2 binomials first and then take it times the monomial in front, or multiply 4p squared times the binomial and then times the binomial. But you will go back, I promise, to the example at the beginning. So go ahead now and practice with your IXL, then take your quiz. I would like you to get at least 8 of 10 out, so please retake it. I highly suggest that you write down your answers because that will tell you shouldn't have to figure it out again. If you didn't do well, you could go back and try to maybe figure out your mistakes and start starting over again. And have a wonderful summer, because this is the last things you have to do for me. It's been a pleasure teaching you. Good luck at the high school level. You are going to do amazing things. And if you ever need help, please come back and I would be happy to help you.